I'm Amit Mishra. I'm originally from India, and then I did my PhD in Scotland, and then I worked for a while in India, in Australia, some parts in Europe, and then I ended up at University of Cape Town. Currently, I'm an associate professor in the electrical engineering department. I mainly work in the domain of radar, and we use radar for all kinds of things, starting from military to agriculture and satellite radars for defense and security as well. The radar is actually an acronym, and it stands for radio, detection and ranging. And if we break the acronym, it's quite clear what it does. So we can find radar in almost every sphere. If you go to the airport, we have got what we call airport traffic control radars, so ATC radars. And let us say if you think of military, then of course radar is everywhere. But even for humanitarian applications, for example, let us say a building has collapsed by some disaster. Now when the building has collapsed, optical lights cannot penetrate through the building. So if we want to see if there are some trapped human beings, then also we need radars. And let us say, for example, we want to estimate what might be the yield of wheat or some kind of crop in agriculture. In that case also we can use the radar images from satellites to estimate that. So if you have stood beside the railway crossings when the train goes past you, so when the train is approaching you, you can actually sense a higher frequency. The pitch gets more higher, like that. And while when the train is going past away from you, then the frequency of the train sound seems to get lower. That's what is Doppler effect. So when something is approaching you, the frequency of that emitted signal, that becomes higher. And when something is going away from you, the frequency reduces. That was invented by a scientist named Doppler, and that is why it is called Doppler's effect. So let us say we have transmitted frequency X. When it comes back, it is slightly higher than that frequency. That implies that maybe there is a target which is approaching us. And if we measure that difference in frequency accurately, we can also find the velocity of the object. So now we can detect, we can find the distance, we can also find the velocity of the object. One of the radar system we are developing now is which we call drone SAR. So it's a drone based radar that can be used to take pictures of what is happening on the ground. And the main application of this thing will be in agriculture. So as I have told just now, in agriculture we can also use optical images and fly the drone and take pictures. Optical images give us information, but to some extent. If we use a radar on the drone as well, that will give us much richer information. And radar can also tell about the kind of crop that is growing, the amount of moisture in the crop, and if there is a water log, what is the level of the water, and even the shape of the leaves of the crops. So that gives us a lot more information to do some kind of analysis and tell, okay, this crop is this kind, and this crop seems healthy, or this needs more water, or whatever. Here you can see a small Doppler radar. So it is small because it uses a very high frequency, and it doesn't need much power. So it can be used to detect human beings. So you can actually install in your home or in your gate, and if something moves around, it can detect the movement. So we have discussed that Doppler detects velocity or movement. Now if you think of the way human beings walk, so we stand on two legs and we walk. And if you look at the way animals walk, they walk on the four legs. So even if the main velocity might be the same, those micro velocities, the small velocities of different limbs and legs and hands, they are different. So this thing can give us a nice signature, if we can call that, of different human beings and animals. We are trying to use the data from this to distinguish human beings from animals. And if you think of use of that, so that can also be used in detecting poachers in our forest. So let us say in a forest we are expecting only the movement of animals who walk on four legs. And if we detect something that is walking on two legs, that's a quick indication that there is somebody who is not desired here who is walking around. I think it's a great field, and most of the times people kind of get confused that if I read radar, I have to do radar for all my life. That kind of sounds boring. whether it is radar or data science or life science, if somebody says to you that, okay, you did this thing, that's what you will do for all your life. That doesn't happen like that in real world. So in real world, things change, new areas come, and what we teach in university is actually how to train your brain muscle to get a new problem and solve it. So you may use that power to solve a problem in radar, but that way of tackling a new problem can be applied anywhere.